program is a set of instructions for a computer to follow. Some common programs are you're almost dealing with it every day. Your email program, word processors, video games, bank ATMs, your audio system or multimedia system in your car, in your vehicle, all use programs. Now you need to remember these two terminologies, running and executing. So when the program follows the instructions, the computer instructions, we say that the computer is running the program or executing the program. Every program, when the computer wants to run it, must have data. So when computers want to run a program, they receive the program. In addition, they receive the data. The results that programs are given us either as a message on the screen or a report, whatever it's called, an output. This is a picture of how computers run programs. If this is in the middle is the computer. So if the computer wants to run a program, it needs data, which is input. And after the program is running or executing, it will give an output. So sometimes the computers here and the computer and the program are considered as one unit. But usually the computer takes the program with the data, run the program or execute the program, and it gives the output. The operating system, I have already mentioned that. If you have a machine, then you cannot operate on this machine without an operating system. Operate, it means if you want to run programs, if you want to deal with the hardware, you cannot do it by yourself. So the operating system will help you to do this. Long time ago, maybe in the 80s, operating systems were made by giving commands in text. So if you want to run a program, then you have to write the command by yourself. Later, the operating system being made advanced by using mouse and icons, clicking. So it does the same job. But before they were typing the command, and now you are executing the command by pointing and by double clicking visually. So some of the operating systems that are famous or popular, Microsoft Word, iOS, Mac, Linux. This also can run on desktop computers, Unix on servers, and etc. We will come now to the programming languages part. When we say a programming language, it means a language that you should communicate with the computer. So the computer can understand only machine language. See, it is at the lowest level, which consists of zeros and ones. Of course, engineers, if they want to understand the command, if the commands are written in machine language, they have to open a technical book, and for each combination of 1 and 0s, they look at it and see what is the instruction. So for example, maybe here, this is the first, these bytes, sorry, these first bits. Maybe it is a command for loading a value into a register inside the CPU. But to read it in 1 and 0s is difficult. So engineers, what they say, okay, instead of dealing with 1 and 0s, how about if we give those 0s and 1s a label? If these combinations of 1 and 0s, it means load a variable B into register inside the CPU, then we can give it a label load. So this line is the same as this line, but the difference that here is written in keywords and here are written in numbers. Both are machine languages, but this one is in lowest level in 1 and 0, and this one is called assembly language. So the difference is that representation, but they are the same. So assembly and machine language, the instructions are one-to-one. One instruction in low level is the same as one instruction in executable level. But here in numbers and here we have keywords. The other level of languages is high-level language. And high-level language is different than low-level language. High-level language is a language that the human or ordinary people in Nas al-Adiyin can read it easily and also can program easily. So if you want to program using low level, it's difficult. And not everyone can understand these commands. Load, it stands for multiply, div stands for division. Engineers should understand this because they are programming the CPU. So for ordinary people, nas عاديين, if we want them to write a program to the computer, we should not ask them to understand the hardware. We just tell them, write the command, and then we will translate it to you in low-level language. So this is a language that a human can understand easily, and this is a language that the machine or the computer can understand easily. But there is a problem. Here in top level, we have high-level languages, examples, Java, the one that you will study, C language, Pascal, Python, some script language like, now it doesn't come on my mind, but anyway, there are other programming languages, C Sharp, Visual Basic, etc. And for low-level languages, it comes in here at the bottom of the picture. Now, human can easily understand high-level languages, but problems that computers do not understand this language. And for machine language, this is the language that the computer can understand, but again, ordinary people cannot understand it. So there is a gap in between. To fill this gap, there is a program in the middle called compiler. So if you want to translate a high-level language into machine language, then we need a program in the middle to do this for us. For, as I said before, ordinary people, they don't want to bother with the machine language. They just want to go open an editor, type the commands in Java, and click a command. It will execute the program immediately. This can be done by a compiler. So what is a compiler? A compiler is a program that translates from high-level language into low-level language. These are some examples. Yes. Yes.
Doctor, how does the computer understand the compiler? So
it depends on the compiler. Where are you running this compiler? If you are running this compiler on Windows, and there are plenty of compilers, this is the one that you will study in this course, then you just open that compiler, write your program, click a command, and it will do it automatically for you.
Okay, thank you.
So the compilers are already made by using high-level languages, but at the end, they are converted into executable code. You put it on your computer by clicking it, it will be installed on your machine, and then you can use it, will do the translation for you. We will do this in the lab and also in the lecture, showing you how to write a program in high-level language and use the compiler. Any other questions?
No, thank you.
Okay. So as I said before, computer hardware, the CPUs, do not understand high-level languages. So therefore, a high-level language program must be translated into low-level language, and this is translated by a compiler. Now, when you ask me a compiler, what does it mean? It means translating a program from high-level language, low-level. It is translating. There is another word in English for translating. It is called interpreting. The difference between the two is that translation, maybe you translate word by word, but interpreting, no. You need to see what is the meaning, and then you translate it. Maybe one sentence, you try to interpret it with more than one sentence. In Arabic, translation, tarjama, interpreting, tafsir. So for the Holy Quran, for example, we don't translate it. We interpret it because the phrases have meanings. So we cannot just simply directly translate the words of the Holy Quran. So compilers translates a program from high-level language to low-level. You compile a program by running the compiler on the high-level language version. And the program you write in high-level language is called the source program. So if I go back, so we have a source program and we have object program. Just remember these two: source, المصدر, object, is the targeted program. So when I go back to the picture, here we have the source program. This is the one that you are going to write in the lab. And once the compiler converted into a file, executable file, then it will be called object file, which will be in here. The problem with compilers, okay, is that they are very sophisticated. Very sophisticated in terms of programming, in terms of size. And if someone would like to develop a compiler, it needs a team of programmers. So this is why big companies develop compilers. Most high-level languages need a different compiler for each type of computer. And why we need different compiler for each type? Can somebody answer that question? For example, for laptop, iPhone, and Samsung, why we need different compilers for each of these machines?
Because of different CPU.
This is one thing. This is different CPU because different CPUs have different machine languages. Correct. Now, most compilers are very large in terms of speed, size, or maybe in terms of money also. So if you want to buy a compiler, it is very expensive. This is why usually companies buy compilers. So let me just have a scenario on this picture, and then I will go to the next topic here. Suppose now you would like to develop a game. You know, if you want to develop a game, then you need a language that will produce a machine language that is fast. So most of the games are developed by C++ language because this language is close to the system. So for example, if I want to develop a game on a PlayStation, so the PlayStation has a machine, it has its own CPU by Sony. So they have their compilers, and once they develop the game, they put that program on a CD. Now this CD, I cannot run it on a Switch console by Nintendo. Why I cannot do this? Because Switch Nintendos, they have different CPUs. So the company has to buy another compiler for Switch. Now if they want to develop the same game on PCs, then they have to buy a compiler for PCs. This is why if a game has more than one version on different platforms, it becomes expensive, around 35, 30 BDs. Why? Because the company has to pay a lot of money for their compilers. And I cannot take a CD for PlayStation and run it on a Switch on desktop computers because the executable files are different. Java does not translate the object code directly to machine language. Why Java does not translate directly to machine language? Imagine this picture now, this picture. Here, as you can see, we have a PC, and here we have a workstation called Sun, and here we have Macintosh. If these are connected to the internet, and you know that how to use the internet, we use browsers, okay, for looking for the informations. I'm sure that some of you have played a game on the web. So you type the address, and then the game comes on the browser, and you play from the browser. Can you tell me what is the language that they are using for this game? If the executable file, I'm just asking a question for paying attention. I'm not expecting an answer, but if someone would like to answer, it's fine. So if I write this program, for example, and the object code is on Windows, then if you download from the internet this program, then you can run it on your laptop, but you cannot run it on your mobile. Why? Because your mobile cannot understand the machine language of this program. So how to make this game run on all machines? Doesn't matter if it is laptop, if it is mobile, and if it is MacBook, and etc. They say we don't translate Java program directly to a machine language for any of those platforms. Because if you convert the program of Java directly to any machine, then you cannot run it on other machines. They say instead, we must choose a machine language that is universal. Everybody can understand, like a human being. Now, we know that English is the common language. So for an embassy, as an example, if they need to hire translators, let's say for 3 languages like Spanish, Arabic, and let's say French. So they need to hire 3 translators. It depends on what is that embassy. Is it the embassy of, let's say, of Bahrain? So if it is of Bahrain, we don't need a translator to Arabic. We need another translator. So we need those number of translators. But you know, you have to pay money for these 3. They say, okay, we can hire one, but this person can understand a universal language, which is English. And we tell anybody who likes to communicate with the embassy to write their letters in English. And then this translator will translate it into the embassy language. So for French people, they have to give the letter in English. For Italians, they have to give in English, and etc. Now for computers, it is the same. Now if I want a program that runs on every machine, then I need to choose a language that is universal, virtual. When I say virtual, it means it's not an actual language, but it looks like a machine language. So the compiler will translate Java into this language. And this language will go to each of these computers. Now, you need to put an interpreter on these machines. Interpreters are not like compilers. Compilers are big programs. Interpreters are small programs. They translate instruction by instruction. Not, you know, the compiler, for one instruction in high-level language, it gives you maybe hundreds of machine language instructions. But interpreters, no, it translates one-to-one. So this is why the programs for interpreters are small. So you can put on each machine an interpreter. So when this program is, let's say, transferred over the internet to your machine, then the interpreter on your machine, of course, the interpreter understands the machine language of your machine. When the interpreter receives this program in this language, universal language, it will translate it directly to your hardware machine and will run it in here. And also, if this program is run on Sun workstations, then the interpreter that translates from this universal language into the machine language will do it for you. So what is this language? It is called bytecode. So I'll show you a picture of a bytecode and I will come back for you. This is a Java program and this is a bytecode. If you go back, sorry, I will flip quickly. See this picture in the middle? In the middle, you see it? Maybe this is an assembly language, which is a machine language for a CPU that if you run this program on other machines, you cannot run it. So this is another language of assembly language. Let's go back. And here, compare these 2 columns. This is Java program, and this is bytecode. See now in here, for example, see this line, it says get X. In Java, you write one command, return X. So in here, you are writing return X. But see how many lines we have for only one line in Java. So 1, 2, 3 instructions in low level. This language bytecode is virtual. It's not run by any machine, but it is used as a universal language. It's like English. So if I go back to this picture, so if I want, so this is the interpreter that understands English. If this is the embassy, and this is another embassy, so any person would like to communicate with those embassies should send a letter in English. So the compiler will translate the program into bytecode, and the interpreter will translate the bytecode into the machine language of this machine. This is why it's called portable. So the game that I was talking about in the beginning of my question is that the game is translated into bytecode as a file, and this bytecode is sent over the internet. When you request for this file, when you type www, This file of the game will come into your machine in bytecode, and your operating system will give it to the interpreter, and the interpreter will translate bytecode into the machine language, and your machine can run it on your computer. As you see that there are two steps of translations, so this is why Java is not good for game development, because it is suitable for web applications. Because you know that when you write a web program, it doesn't depend on the speed of the machine, it depends on the speed of the internet. If you have a low speed internet, then the data will be slow coming to you. So the CPU is not involved in here. So if you will have heavy calculations, then you have to use a language that it translates directly into the machine language. Game development, for example, is not suitable to use Java. Java is not good because it will be slow. So a bytecode, the Java compiler does not translate Java program into assembly language, which is machine language, but instead it translates a program into bytecode. So what is a bytecode? It's a machine language for a virtual, hypothetical, افتراضي computer, which is called Java Virtual Machine, JVM. And this is why maybe for some of you, if you have a laptop and the interpreter is installed, sometimes you receive a message on the taskbar. It says, please update Java. This is the one I'm talking about. This is the interpreter. So this is the Java virtual machine. So interpreters translate each instruction into machine instruction and run it immediately before translating the next instruction. So it does translating instruction by instruction. Not like the compiler, it translates all together and put it in executable code. So a bytecode is easy to translate into machine language, and the program that it translates bytecode into machine language is called interpreter, JVM. This is the big picture of how your program is translated and run by any computer. First, your program is compiled into bytecode, and then the JVM, which is the interpreter, will translate bytecode into machine language and give it to the computer. Of course, the computer needs data, so it takes the data and the machine language of that program and will give you the output. In Java, since it is used for internet applications, if your program should run on your desktop, then it's called application. So if you are not intended to write a program so that it can be used around the world, then it's called application. But if your intention is to develop a program that can be sent over the internet by browsers, then it is called applet. And when you write a program in Java, you specify which type of these. So for applets, you have to write a specific commands, and for applications, you have to write a specific commands. Here they are called forms, and here they are called applets. If you want to run your program, then you need a compiler. And you will use a compiler. There are compilers on Mac, there are compilers on Windows. And the one on Windows, there are also plenty. Maybe one of them is IntelliJ, maybe the other one is JGrasp, another one maybe JDoctor, and there are plenty of clips, and there are plenty of compilers. In my lecture, I'm going to use a compiler called JGrasp. It's small and fast to run on your computer, but IntelliJ is for professional people, and you need a computer that is fast. And we also in the lab, they will teach you how to use these programs. They are called IDEs, Integrated Development Environment. So it's a text editor like Microsoft Word. You type the program, and then you move the mouse to the menu. You click a command, it will run the program for you. The program, when you save it in Java, it will have extension .java. And when it is converted into bytecode, then it will have the extension .class. And they will exist in the same folder. So when you compile your program, you will see another file with the same name of your program but has extension .class. Inside it, it is the bytecode.